My name is Dr. Clifford Glade. I'm a Director of Thermal Custom International Packaging, also known as TCIP. TCIP makes insulated cases called totes and the phase change material or PCMs that maintain them at specific temperatures of refrigerated, frozen, and ultra cold. Various PCMs are in custom housings that fit in different size totes. Depending on what you're trying to accomplish, the right PCM and the right tote will maintain specimens refrigerated, frozen, or ultra cold during cold chain transport. It's fairly easy to tell when a phase change material or PCM is ready to be used. What we recommend is freezing the unit for 24 hours until the PCM becomes opaque and hard. You can't move this outer shell. When the PCM is not frozen, it's clear, and you can see that it's liquefied. We're going to provide you with a chart to show you how long you need to freeze each PCM in various types of freezers, regular freezers and ultra cold freezers. Some of our PCMs have to be frozen in ultra cold freezers, particularly the -21, because a normal freezer does not get cold enough to freeze the PCM. -16 PCM will freeze much quicker in an ultra cold freezer than it will in a normal freezer, but it will freeze in a normal freezer set to -20. If you take a moment to look at the chart, you'll notice that we have it broken down to an ultra cold freezer and a regular freezer. The ultra cold being -40 degrees and a regular household freezer being -20 degrees. In the ultra cold freezer, a 5-pound PC0 was frozen in 3 hours. In the ultra cold freezer, a 5-pound -7 was 90% frozen in 3 hours and completely frozen in 6 hours. In the ultra cold freezer, a PC -16 5-pound was completely frozen in 22 hours. In a -20 upright freezer, a 5-pound PC0 was completely frozen in 7 hours. A 5-pound PC -7 was completely frozen in 22 hours, and a 5-pound PC -16 was completely frozen in 34 hours. Therefore, we at a minimum recommend 24 hours for PC0 and PC -7 and 48 hours for PC -16 in a regular freezer. TCIP custom hard shells come in custom sizes to fit our various size totes. The 3-pound unit, which is available in 0, -7, -16, and -21, is custom made to fit our small and medium tote. The 2.5-pound unit, as well as the 4-pound unit, are custom made to fit in our large tote. In the smaller totes, we use one custom hard shell per tote. In the larger units, we use 2 custom units per tote. Depending on the duration that we want the precise temperature to be maintained, we try to keep the tote as light as possible. So if we can use the 2.5-pound, we use the 2.5, and if we have to go to the 4-pound, we use the 4-pound. TCIP makes 3 size totes for insulated couriers: small, a medium, and a large. The smallest tote comes standard with a carrying strap and has a document window on all 4 sides. Custom graphics will be printed on top that specifically delineate your facility. Inside the insulated tote is a formed well that's almost impervious to chemicals. The well is insulated on all 6 sides when closed. The medium-sized tote can come with a shoulder strap, but it's an extra. The same custom graphics can be printed on the lid of the medium tote, and there's a document window on all 4 sides. The formed well is larger and is capable of transporting more specimens and is insulated just as well on all 6 sides. The large tote has a document window also on the top next to your custom graphics. There's also a document window on both sides and the back for transport of paperwork with the specimens. Another difference with the large tote is there is a separator inside. When the separator is in place, we can set up 2 temperature zones. Alternatively, we can put the separator in what we refer to as position 0 and maintain 1 temperature zone. The totes are also available in ballistic nylon, which is stronger than the polypropylene. Here's an example of the small tote in ballistic nylon. Everything else remains the same: carrying strap, document windows, formed well, and insulation. The totes are also available in an extreme duty hard shell under special order. The extreme duty hard shell is almost indestructible. It's waterproof and capable of withstanding a 75-foot drop. Everything else is identical. The same form well, the same insulation on all 6 sides, the same almost indestructible well that's capable of being cleaned with any type of harsh chemical. Let me take a moment to show you how to properly load the totes for a refrigerated, frozen, and ultra-cold specimen, as well as blood transportation. We're going to use the small tote. If we're going to put a frozen specimen in the tote, we recommend that you freeze the specimen prior to putting it in the tote. The PCM will freeze the specimen, but there's only a finite amount of energy in each PCM, and we're needlessly using it to freeze the specimen. So the frozen specimen goes first into the tote, and then you put the frozen PCM, which is either the PC-7, PC-16, or in this case the PC-21. With the small tote, we recommend 1 3-pound unit on top of the specimen. Zip it up. You're ready to go. Next, let me show you how to properly use the small tote to move refrigerated specimens. The refrigerated specimen, once again, should be coming out of a refrigerator. The PC0 will bring them down to refrigerated temperature, but you're using up energy that could better be used to maintain them a longer duration. The 3-pound PC0 is put on top of the specimen and zip closed. You're ready to go. Next, we're going to use the small tote and set it up to transport blood. In the United States, blood must be transported at 1 to 10 degrees Celsius. We're going to open the small tote. We're going to put the blood inside the small tote. And the difference with the specimens, we're going to put a custom insulator into the small tote to separate the PC0 so it doesn't touch the blood and make it colder than 1 degree. And put the 3-pound PC0 on top in the small tote. Zip it up. You're ready to go. Let's talk about the special case of allografts. In the United States, allografts must be maintained at -21 degrees if we want the possibility of placing them back into long-term storage if we don't use them. The allograft, after being placed in the tote, we add the -21 degree phase change material, and we recommend incorporating a data logger so that we can prove that the allograft was always maintained at less than -21 degrees. Close up the tote, and you're ready to go. With the medium tote, the same 3-pound PCM unit is used. Now, there's no reason you can't use 2 3 PCM units if you need a longer duration. What we try to do is maintain the units as light as possible. The same insulator is used in the medium tote as those used in the small tote. With the large tote, the procedure is basically the same, except different size PCM. Depending on the duration that we desire, we either use the 2.5-pound or the 4-pound PCM, one above and one below the specimen. So we put the PCM on the bottom, We put the specimen on top of the PCM and then a PCM on top. If we want to maintain frozen PCMs, we either use -7, -16, or -21. If we want to use refrigerated PCMs, we use PC0 above and below the specimen. The large tote is capable of transporting 24 500 ml units of blood. The loading process is the PC0 goes on bottom. Again, you don't want the PCM touching the blood, so the custom insulator goes on top of the PCM. Then the blood goes in, all units of the blood, whether it's 250 ml or 1000 ml or 500 ml, followed by another custom insulator, and finally a PC0 on top. There are two size PCMs that will fit in a large tote, 2.5 pound and 4 pound. Depending on the duration you are trying to accomplish, you can use either two 2.5 pounders or 5 pound totals, or two 4 pounders or 8 pound totals. Our goal is to maintain the tote as light as possible. Completely loaded with 24 500 mLs of blood, two 4 pound PC0s, this tote still weighs less than 50 pounds. Let me take a moment to discuss the large and small tote blood transportation summary chart, which is available to you in the brochures, the PowerPoints, as well as this video. Let's use by way of example test 12, large tote. 8 pounds of PCM, PC0, was used in the test. The test lasted 13.63 hours, 1 to 6 degrees, and 31.43 hours, 1 to 10 degrees. The importance of those temperatures is 1 to 10 is the requirements in the United States for transport of blood. Any deviation outside of those normals in the blood can't be used. The 1 to 6 is the storage of blood. So we provided you both time frames. Depending on whether the tote was in extreme temperatures, such as in test 8 and test 7, or whether the tote was opened, test 9 and test 10, will depend on the duration. And you can see how each various change has an effect on the duration. In the small tote, you can see that in test 33, it lasted almost 16 hours. And depending on extreme temperatures, the same deviation. Extreme temperatures, opening and closing, will all affect the duration of the precise temperature range. So whether you're transporting refrigerated, frozen, specimens, allograft, blood supplies, or organs, TCIP makes the proper size and the proper temperature to get the job done.